Hello, this is our lesson for Tuesday, September 15th. We're going to talk about measurement today. Yesterday we talked about conversions, and today we're going to use what are we going to use those conversions for, right? We're going to be doing different measurements, and now that we know how to convert one measurement to another, let's talk about actually doing those measurements. So the first thing I want to do is start off with, well, what's a measurement? A measurement is a comparison to a standard. And what do I mean by standard? This is something that everybody is going to recognize, right? A foot. We're all going to agree on the length of a foot, whether we're in Ohio or whether we're in Kentucky or whether in California or any place else in the world, we all are going to agree on the length of a foot. Right? Well, why is this so important? Well, long ago, well, a couple hundred years ago, when people used to measure the height of a horse, and they would talk about the unit they would use for that would be a hand, right? So a hand. Now, let's think about that for a moment. If I told you that I had a horse and it measured 18 hands tall, am I talking about my hand? Or am I talking about your hand? Am I talking about the president's hand? Whose hand are we talking about? So it was not a standard measurement, right? It didn't do very good. That did a great approximation, but you could still be off very easily by quite a large factor because a large man's hand would be very different than a small woman's hand, right? So we need a standard. We need something we all agree on what is that height? What does that length mean? Or what does that unit mean? Well, there's two different systems we use of measurement. And the first one I want to talk about is SI. System International is what SI stands for. Usually we call that the metric system. We also have the English system that most of you are more familiar with. But in science, we don't use it. It's rather clunky. It's very clumsy and difficult to use in calculations. Whereas the SI system, the metric system, is made to make calculations easier. So I think you'll all like it once we get into using the system a little bit more. And it's a universally accepted standard for all math and science measurements. In fact, I think there's all but like 3 countries in the world that use this system. Unfortunately for us, the United States is one of them. So let's talk about the base units. The base units. And what do I mean by that? Our base units are the base things. What kinds of things can we measure? Right? I'm going to start off with one. Our abbreviation for it is L. L is short for liter. It's our abbreviation for liter. Hopefully you guys have heard of that before. What's a liter? It measures volume. Right? Measures volume, how much space something takes up. The other base unit I want to talk about is we use the abbreviation G for gram. Right? What is a gram? This is something that measures mass. Our next unit, our next base unit is Celsius. And the little c, that little circle, and then it stands for degree. And then that little circle C, degrees Celsius, is what that abbreviation stands for. And what do we measure in degrees Celsius? We measure temperature. And finally, the last one I want to talk about here is we use the abbreviation M for meter. And hopefully you guys know meters are a measure of length or distance. So those are the 4 fundamental kinds of things. Really, there's a fifth that's common to all of us, and that's time. Right? We use seconds and minutes and hours and days and weeks and years, months. Right? Those are the units for time. But since that's the same across all the systems, we're not going to go into that in detail here. All right. Now that we've defined what our base units are, liter, gram, degrees Celsius, and distance, let's talk about or meters for distance. Let's talk about how we go from one smaller unit of that measure to a bigger unit, or to a smaller and smaller and smaller. Right? To put that in terms of the English system, right? If I said, let's take our base unit for distance in the English system to be feet, what's the next unit bigger? The next unit bigger is yards, right? So that'd be 3 feet to a yard. What's the next unit smaller? That'd be an inch, right? And 12 inches to a foot. Right, so this is what I'm talking about here. How do we go from one unit of measure for that base quantity to a different unit, a bigger or smaller unit of measure for that base quantity? And the metric system makes this really easy because it has a standard name, right? A standard name. We don't have ounces and gallons and quarts. which we have for volume, compared to feet and inches and yards for distance. It's very clumsy. Each one's different. The metric system, it's very similar. Right, so if you look at the slide here, right in the middle, there's an M, and we'll call that our base unit. That could be a could be a meter, could be a liter, could be a gram, could be a degree Celsius. Right, that's our middle one there. That stands for our base unit. Now, if we go up by a factor of 10, that means we're going to the left. The little d for deca, that is a 10 times a 10 meters. So that would be 1 decameter would be 10 meters. Move your decimal point another place to the left, and you get hectometers. Right, 1 hectometer is 100 meters, right? And then you move to the right, it's the other way around. You're moving your decimal point to the right. So you have 1 meter, move your decimal point to the right, you have 10 decimeters. Move it another place to the right, and you have 100 centimeters. So hopefully this stuff you've seen before. Now, if it helps to remember these, we're going to use just these main 7. I mean, you can go on and on, higher and higher and smaller. But we're going to use this KHD, those prefixes, kilo, hecto, deca, and then deci, centi, milli. And in the middle, we're going to have that base unit, which we usually will signify by an M for our shorthand. And if it helps to remember the order of these, try remembering this little fun saying, King Henry died Monday drinking chocolate milk. So it'll help you remember kilo, hecto, deca, your base unit, then deci, centi, and milli. All right. Now, we talked yesterday a bit about conversions, and that's great when we're converting values. We want to take this one step further, and this is going to lead us on to our lecture for Monday. The key idea here is that anything we measure is going to have some degree of error. Some degree of error. It depends on how good our measuring device is, right? Our measuring devices do not have infinite precision, right? As opposed to a counted value. A counted value does not contain any error. Well, let's think about that for a minute. What do we measure versus what do we count? And why do counted things not have any error? Well, what if you had 5 sheep or 5 dogs or 5 cats, 5 something, 5 of any animal? You could have exactly 5 of them. You wouldn't have 5.22, not unless you've done something really weird and you've cut up one of your sheep for butchering or something, but we're always going to have a whole unit of sheep. I mean, we have 1 sheep, 2 sheep, 3 sheep, and there's nothing we're measuring here. We're just counting them. Can you point to them? 1, 2, 3, 4, 5, right? Because we can count them, there is no error. There is no error. Measured things, again, do have a certain amount of error. So here I've got a couple pictures of things that we use to measure, right? We have a scale to measure mass, we have a stopwatch to measure time, a ruler to measure distance, a graduated cylinder to measure volume. So these are different tools we use to measure those 4 fundamental base units. But each one of these has error because it's measuring, right? If we look at our balance here, they can go to 0.01 grams. Right? They can't read to 0.001 grams. They don't have that kind of precision. Right? The stopwatch you see here, this is what 12.60 seconds. So it can measure to 100th of a second, but it can't measure to the 1000th of a second. Right? Similar with our ruler. Our rulers are going to typically measure to a millimeter. Right? Our graduated cylinders are typically going to measure to a milliliter or a tenth of a milliliter, depends which one you use. Right? So all of them have a certain amount of precision, and because they only have a certain amount of precision, they have a certain degree of error. It kind of goes hand in hand. Okay. Right. So let's talk about this a little bit deeper. Let's say you run the 100-meter dash in 10 seconds. So any of you track athletes would probably say, wow, that's a little slow. You should be able to do a little bit better than that. But for the sake of our argument here, let's just say that you ran that 100-meter dash in 10 seconds. Well, okay, 10 seconds, that's in the ballpark. But should we say 10.0 seconds? And I'll talk to you Monday about what the difference is between 10 and 10.0. Would we say we ran it in 9.9 seconds? Well, our stopwatch could tell you 9.9, could tell you that tenth of a second. How about 9.87 seconds? Again, yeah, our stopwatch could tell you 9.87 seconds there. But could our stopwatch tell us 9.868? No, it doesn't have that level of precision, right? So at some point, we're saying we guess, right? Our stopwatch can say 9.86, might say 9.87. It's really somewhere right around there, right? Give or take a few thousandths of a second. That's what our answer is going to be. So at some point, we're guessing at what that final digit is. We're truncating, if you will. We're getting rid of all the numbers to the right from where we stopped. Okay, so that's what we're talking about, degree of error, how accurate, how much precision we have. So when we're using our tools here, when do we guess on our various tools? So it's easiest to think of this with a graduated cylinder or a ruler. We're going to estimate to 1/10 of the smallest place on our device. So if we look at a ruler or we look at a graduated cylinder, we had those tick marks, and we were talking about those increments earlier, right? We're going to look between two increments, the two smallest lines, the two closest lines on our measuring device, and then we're going to estimate 1/10 of the way in between here. Now, 1/10 gets kind of hard, so that's why in the video earlier I was talking about, well, let's estimate halfway. Are you halfway in between them? Are you a little bit more than halfway between them? A little less than halfway between them? And I helped you see how you could estimate to maybe about a quarter of the way, which quarter of the way, and then maybe a little bit smaller than that. But we're going to try to get to 1/10 of that division between here, right? So if this is 1 and this is 2, we want to try to get to 1.1. Maybe it's all right. We want to get that one more layer of precision from what our instrument says. And the limits of our instrument tell us how far we can round. So in the example here, I was talking about 1 centimeter, 2 centimeters, right? The degree of accuracy of our instrument here, right? 1 centimeter, 2 centimeters, that's telling us how accurate it is. That tells us where we need to round, right? And if we had a more accurate one that was millimeters instead of centimeters, we wouldn't have to round as far, right? Because the tool, it already has 10 times the degree of precision. So we already talked about a stopwatch measuring to about 1/100th of a second. Would you believe somebody who said they could run the 100-meter dash in 12.98654852865 seconds? Well, geez, I'd hope not. Our tool doesn't measure that precise. That's a heck of a guess to go to that many decimal places when our tool can only tell us it's 12.98, 12.99, 12.97. It can't tell us all those additional levels of precision. So, right, our precision is based on how good our instrument is. Right? Tomorrow we'll have an activity that will demonstrate some of that. And in today's folder, I have put 2 files in the bottom, near the bottom. One of them is a picture of 3 different rulers which have 3 different levels of precision, and the other one is the worksheet that I want to do tomorrow. So if you have a printer and can print those 2 worksheets out, to do that today, please, so that when we have class tomorrow, we can get a jump on doing that, because we have a lot to go over tomorrow. We're going to have an activity. We're going to talk about what we're going to do next week as we start coming back to school. And of course, we have our quiz will be on Thursday this week, since we don't have class on Friday. All right. Thanks a lot, guys. We'll talk to you tomorrow.